Greetings, Padawans, and welcome to our talk about how to use the Force to effectively test Android apps. We are Zan Skywalker and Yoda Jackson, and we're Jedis from the West London Council. So let's start with some news. So, not a month ago, in case the latest news haven't reached you yet, Alliance brass gathered in the Moscone station on the moon of San Francisco to talk about the latest and greatest achievements in our war against the Empire. So the biggest piece of news is the new M series of droids that are coming this year to replace our trusty L units of yesteryear. And there is also the new permission handling system. So it'll allow us to more finely define what permissions we allow on our apps and prevent evil Empire's flashlight apps to access our contacts and the like. There's also the design support library that will enable us our ships to have a more uniform look and feel, and the data binding library to improve the efficiency of our hyperdrive cores. Again, on the testing front, the biggest news here has to be the unveiling of the Cloud Testing Lab by Google. So it's joining the likes of Xamarin, Appium, and others as a provider of real devices in the cloud to test your apps on. But that doesn't stop here. It also is planning to integrate testing on emulators, so we'll see more availability and flexibility straight from the guys who are building the platform. And this is very exciting news, but now off to Yoda Jackson to talk to you about our attack plan.
So when you go to attack a space station the size of the Death Star, you need a pretty special plan to do this. And thankfully, the schematics that R2 retrieved have given us a real clear idea of how we're going to go about this. So what you don't need is you don't need to hit it in one big shot from your MC-80 Star Cruisers. What you need is to use more smaller targeted attacks from your X-Wing unit tests and from your more sort of heavier attack vessels using your functional tests. So first, let's have a quick look at the J Unit 3 and the J Unit 4 attack formations. Now, the basis of you doing this with a unit test is to hit fast and to hit often. Now, of course, this means that you can only take on a single TIE fighter at any one time, but it's still really effective because you can do a lot of damage. And up until recently, you've only had J Unit 3 available in Android. And one of the problems with this is that J Unit 3 didn't have any other capability than running within the Android app emulator. Or you could have to run it on device. And that meant it was really, really slow. So J Unit 4 brings a little bit more to this. And I'm going to talk about that a little bit more in a minute. But the other additions are the way that it cleans up your tests, the more way that you can semantically sort of have control over the test classes. So in the early days, we had these two formations. We had our plain old unit tests, and we had our activity instrumentation tests. And I mentioned before that the unit test would have to run on either the Android virtual machine or on a physical device, and that caused quite considerable amount of problems because it generally ran really, really slow. The other problem is that you are managing your dependencies, and when you try and manage dependencies in an Android system, trying to manage out all of Android is really, really difficult. So even if you could manage to get this set up and you could get your unit tests running on your JVM instead of the Android virtual machine, the dependencies would cause you a whole host of pain. So what do you do? Do you abstract all of these Android dependencies? Do you write your own interfaces around those? I mean, you could certainly try that, but to be brutally honest, it'd be about as painful as throwing yourself into the belly of the Sarlacc pit. And after you've tried writing all of this abstractions, you will voluntarily go ahead and do that. So then you've got Roboelectric. And Roboelectric tried to solve the problem by introducing its own little test runner. And this test runner would allow you all of these mocks around the Android system. So you've got things like abstraction on your GPS service, on your preferences service. But the problem is that Roboelectric isn't in sync with Google. So Google will update something, Roboelectric doesn't update, and you've got to make a choice. Are you going to update the SDK and the or are you going to not run your functional tests? And so the whole pain process of this actually makes the Sarlacc pit feel like a Sunday morning. Now, Google did listen, and eventually they fixed some things. So recently what we've seen is developments with the 1.1 tools, that we've got the capability to use these JUnit 4 tests. We can run them on our JVM on our machine instead of in the VM. And we've got the ability that we can actually got a full suite of Android mocks. Now, these mocks are provided by Google. So that means that they're tied to the SDK version. It means that when the SDK updates, so do these mocks. So that covers the majority of your sort of your fast attacks. You still need to look at your surface level attacks. And we should never underestimate the damage that can be done by a surface-mounted turret. So I'm going to hand you over to Zan, who's going to talk a little bit more about that.
Okay, so as we don't want another half on our hands, we realize that, X-Wings aren't going to cut it. So we need a basically bigger ships to at least buy our X-Wings time to find those exhaust ports. So our capital ship in the Rebel fleet, this one, that's the UI Automator. It takes a long time to spin up its lasers, but when it fires, it's really, really effective. It's also the only option we have if you want to go outside of your app. So if you want to access like settings or notifications or the application drawer, you would use the UI Automator. But it's slow and it's expensive to run. So the bulk of our fleet is built on the trusty old instrumentation platform. That allows us to perform test events on activities, services, providers, and the like in order to wreak havoc on the Imperials. So this platform's really old. It's been with us since version 1 of the SDK, and it's been updated over the years. And examples of ships that are running on it are Cylindroid, Robotium, or Espresso. So these only allow attacking single application at a time, but you have a more fine-grained targeting system for it. You can mock some APIs and do pretty cool stuff with this. So at M&S, the most heavily used vessel is something called Calabash. This is an alien Pimp My Ride version of Robotium with added BDD torpedoes, preferred by the race of the business people. So the controls for it are not in Java, they're in galactic dialect of Ruby, but it's still easy enough to learn by anyone. So, as I said, it attacks with BDD torpedoes, and those then split into tests that are understandable by us Jedis. So, we define our features in Gherkin syntax, and it's usually done in a cooperation with an admiral, or if an admiral is nowhere to be found, we can use a product owner as well. So, and then we implement those feature steps. And we cover scenarios such as I correctly log in, I incorrectly log in, I log in without the password, I try logging in without the email, I try logging in with an invalid email. And then all of these tests run on devices, and we can integrate them nicely with Xamarin Test Cloud or similar tools to run our acceptance tests on the cloud. In fact, it's so fun to write our tests and fire our torpedoes that we suddenly end up with hundreds of those. And it takes 3 hours to fire them all, which is incidentally exactly 4 times the amount of time it takes the Death Star to target and destroy our Calabash ships with its death lasers. So it's super easy to overdo calabashing, and because it's so convenient. So we must not fall into this trap. So yeah, the tests suffer from reliability issues. It's hard to run them on a box tunnel emulator, for instance. It's slow. Genymotion and Hexam will help, but they are out of the window if you try to run them on a VM. So we're still waiting for a decent solution on a VM, and they also often misfire with crypting messages like HTTP alive disconnected or the like, and the solution is to kill Ruby, kill ADB, kill and restart the emulator and keep retrying. And although powerful, Calabash feels like it's a contender for the most unreliable ship in the universe, right beside the Millennium Falcon.
So the interesting thing is that I've been there. And I've done the whole Calabash thing, and in fact, Calabash is what's got me stuck in this slimy mud hole. You see, the problem with Calabash is the way that it works. It works like a thin veneer which sits on top of your app. It means that you have indirect control over the code, and it's almost like a virtual finger which is prodding your application. So soon your nice functional test suite starts to take days. Soon it starts to be very unreliable. Soon it starts to break. Then Google will go and update something, and soon you don't have a functional test suite at all. So what do you do about this? And I think the key thing is that you've got to look at the benefits. So the benefits of Calabash is one of functional testing. The other is an interface that you get from using feature files. And Google have got you covered with the functional test because you've got your activity instrumentation test cases. From the feature file perspective, there's a little tool called Cucumber JVM. And Cucumber JVM will allow you to run BDD style given when then, and then actually execute activity instrumentation tests. So I recommended giving this a go as an alternative to Calabash. Now, if you excuse me, I'm going to steal his X-Wing and get the hell out of here.
Thanks for the kind words, Yoda, but if your little green ass gets anywhere near my X-Wing, I'm gonna get R2, stick an arc welder somewhere. So, back to the important stuff. Calabash is important, but the activity instrumentation can have the similar problems with timeouts. And if he'd not spent the last 200 years in a swamp, he'd have learned about some new cool rebel technology. So, our Millennium Falcon has just gotten a big upgrade to its hyperdrive core. It's called Espresso, and it's really clever. It's the newest and most advanced ship at our disposal. It's also really precise and ties really neatly with other Android tests. It's got a brand new targeting computer, and that basically uses something called idling resource to look at your thread pool and determine when the app is free and it's time to run another test step. So that's really cool. It works really nice with Espresso version 2.2, but it's not all fun and games. Try to integrate it on a mature project is kind of like taming a rancor. And translating Calabash into Espresso is a whole new process.
So this is really interesting. And actually, the kid's got a point, and I'm quite pleased because I must have taught him pretty well. But the solution around this could be to look at your Cucumber JVM. So use Cucumber JVM. Get that relationship with your business by using the Gherkin DSL. And then integrate that and run your activity instrumentation tests. But use the Espresso framework within activity instrumentation to save you a whole load of pain, certainly around writing 1,000,001 wait statements.
So, far from that, only the best can outrun Imperial frigates, and it takes a special ship to do the Kessel run in less than 12 parsecs. So, here's what upgrades you can apply to your builds to make them faster. So, first and foremost, think of your tests as your fleet. So, you only have that amount of Karelian corvettes and even less capital ships, but you have a shit ton of X-Wings. And X-Wings are cheap, so think of your unit tests as your X-Wings. And the more bigger and elaborate your tests become, they should be numbered in accordance to bigger ships, basically. So a well-architected app with a clean code base greatly helps with that effort. And it allows your X-Wings to do most of the damage where they're really good at. And they're really fast, 100 times faster than the bigger ships. So some things are also easier if you don't test them. Or if you test them manually. Some critical systems, on the other hand, they require duplication, like live support, you want to have double of that. And so consider duplication. You write the appropriate tests for appropriate function, but it's not wise to do 1,000 permutations of a credit card number on a functional level. You want to do that on a unit level where it's cheap. And the most important bit, always mock your API. But make sure you leave in enough integration, on the other hand, to make sure you don't mess up with the config files. And a colleague of mine recently has learned that, and after polishing up a recent release, we started running those tests as well. So if you stick to these principles and others, there's an abundance out there, we're bound to give Empire a hell of a fight.
So in summary, so we've got JUnit 3 and JUnit 4. If possible, you should try and use the latest JUnit 4 tests. You should try and get your separation right. You should try and run these on the JVM as opposed to the Android virtual machine. Use Calabash if you must, but there are better options out there, and the Cucumber JVM solution might be a little bit cutting edge, but it's very interesting. Activity instrumentation, use this. Get your Espresso framework set up inside there, and don't forget, mock your APIs. Don't stub out your endpoints. Make sure that they're hitting through. So thank you very much for listening. We've got a GitHub repo, which should be showing up there, but it's not. So
it is on one of the next slides, basically. There's a bunch of links there and people worthy of following. There's like the Jedi Masters that we all learn from, and user libraries. And here are a couple more tools in the end of the slides if you want to look into more detail. So thank you.
Thank you.